we are talking about properties of rational exponents and radicals. And now we're going to take a look at simplifying the following expressions. And we want to, or do not assume that the variables are positive. And in that case, anytime that we have an even radical, we need to make sure that we are considering both the positive and negative version of that. And we'll take a look a little bit more at that as we go. So the first example here we have is the fourth root of x to the fourth divided by y to the eighth. And so we want to try to take those things out of the radical, and so we want to have them in versions that can take out. So we have to have sets of whatever that number is, so we need sets of 4. And so in the numerator we have x times x times x times x. And in the denominator we have y times 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 y. And that's still under the fourth root. So as we make those sets to pull out of the radical, that's a set of 4. So we can take that out. That's going to be 1x outside of the radical. We have another set of 4 and another set of 4. Those are going to come out and just be 1y outside of the radical. So we can rewrite this as x in the numerator and then y squared in the denominator. So this is the part that we have to pay attention to, the even radical. So when we're using exponents, and let's say that we had x squared was our answer, or x squared was our solution, and x squared equals 9. So there's 2 ways that we can get there. We could say 3 times 3, that is equal to 9, but also negative 3 times negative 3 is also equal to 9. So whenever we're solving, when we have an even radical, we have to be able to consider both solutions. Because if we took the square root of 9 in this case, we don't know if the solution would be 3 or if the solution would be negative 3. So when we're writing our answer, we need to make sure that we account for that. And the way that we do that is we use the absolute value sign. So it could be the absolute value of x. Now, we don't care about the y squared, because negative 3 squared is 9 and 3 squared is 9. So whether y was negative or positive, it's not going to make a difference, because we'll have the same outcome of positive 9. The next example we have the sixth root of 64, h to the 12th divided by g to the 6th. And so we can rewrite that, and we want to rewrite it in sets of 6 so we can see what we can take out. So 64 can be rewritten as 2 to the 6th. H to the 12th can be written as h to the 6th, h to the 6th, and g to the 12th g to the 6th stays g to the 6th. So what can we take out? Well, because we're taking an even root of a value, in that case we have to consider plus or minus. So we can take the 2 out, but we don't know if that 2 is going to be a positive or negative. So we have to account for plus or minus for the coefficient there. And also in the numerator, we have 1h that we take out from h to the 6th, and we have another h to the 6th that comes out. So now we have 2 h's out, which is h squared. And then in the denominator, we have 6 g's, so we can take that out of the radical, and we just get g, just 1 g. Now again, the h squared doesn't matter, because if it's negative or positive, it's still going to be, it's still going to have a positive n value. So we only have to add the absolute value for the g to account for the negative or positive version. And that is the simplest form.